What's up, guys? Today we're doing a video on the rules of exponents. And before I do some examples, I want to click through the notes here and talk a little bit about what each one of these are saying. Just real briefly, we will come back and do an example of each one. If you don't have these written down, go ahead and pause the video now and write them down. Okay, so the first rule, we have the product of powers property. And this is just saying if you multiply two like bases, then we're going to add those exponents together. The power of a power property says if you have some base raised to some power and you raise that to another power, you multiply the powers together. These two are the ones people get confused the most. Here we're multiplying two like bases and adding the exponents. Here you're raising a power to a power, so you multiply the exponents. The power of a product property, this is saying is if you've got two things multiplied on the inside, then when you raise it to a power, you've got to raise both parts to that power. Okay. Some people like to call this distributing. I try not to use that, but if you can think about it like distributing. You're going to raise everything in here to the m power. Now it's important to note that if there's already a power in here, just like up here, you've got to multiply times what's already there. You don't just put it there. If there was a 2 here, you'd have to say 2m. They got to be multiplied together. The negative exponent property says if you have a negative sign, the way they've got it written here is they're flipping the a to the bottom of a fraction and putting it underneath a 1. Well, here's what you got to remember. This a to the negative m, anything can be written as itself over 1, right? So you need to think about this as being a over 1. This is a fraction, a over 1. And the negative sign says we're going to drop the negative sign and we're going to flip the base upside down. So instead of a over 1, it's going to be 1 over a. Of course, it's still to the m power, but notice that the negative sign is gone. So if this was already a fraction, like say this was 2/3 and it had a negative exponent, you flip it upside down, it would be 3/2. And all the exponents stay with their base. So since a was to the m power, now it's still to the m power, it's just flipped upside down. And then there's this extra rule here that a cannot be 0. And that's because that would give you a 0 in the denominator, and that can't happen. All right, the 0 exponent property says anything to the 0 power equals 1. Just a fact, just remember it, anything to the 0 power equals 1. And again, a cannot be 0 in this case. The quotient of powers property, this is the same property as the product of powers property. They're actually the same thing. Up here, when we multiplied like bases, we added the exponents. So now when we divide like bases, we subtract the exponents. Division is the opposite of multiplication, so it makes sense that we would subtract instead of adding. And then the power of a quotient property is actually the same thing as the power of a power property. I'm sorry, the power of a product property. Here we were multiplying inside the parentheses, and then we had to raise each one to the m power. Well, here we're dividing inside the parentheses, and so you have to raise each one to the m power. So this really works exactly the same way as this. We're just dividing instead of multiplying. Okay, so now I want to do some example problems, and I've got a few written out here, and let's just focus on them one at a time. They're going to be sort of following the order that we talked about the rules, although they're not exactly the same, and the examples get a little harder as we go. So let's just start with this first one. So you have x to the 5th times x to the 3rd. So this means you have a like base, so we're going to add the exponents together. So we're going to get x to the 8th. And that's it. Next, you have x to the 3rd to the 4th power. Okay. Now think about this. I want to help you explain why we're doing what we're doing here. X to the 3rd to the 4th power means I've got x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd, right? And remember, we have like bases, we add them together. So what you really got is 3, 6, 9, 12 x's. So it's x to the 12th. In fact, if I were to expand this, that would be x times x times x times x times x times x, and so on. And you eventually have 12 x's written out. And of course, 3 times 4 is 12. So we don't need to write that middle part, but I want you to understand this is where it comes from. And that's why the rule works the way it does. Okay, next we have some things multiplied together inside parentheses, and it's all raised to the 3rd power. Now remember, we said, and I don't like to use this word, but you can think about this like distributing, meaning we need to raise everything in here to the 3rd power. Where people get confused here is when they say distribute, we think about multiplying and distributing, and we multiply everything by 3. Well, in this case, what we're saying is you multiply every exponent by 3, okay? And so, for example, this 2 to the, and so y to the second to the third, that's going to be 2 times 3, which is 6. I'm going to kind of write it backwards here because I want to make a point. That's going to be y to the sixth, okay? X to the first, and this is a 3, so it's 1 times 3, which means that's x to the third. Now, where people mess up is right here. They want to say 2 times 3, and they want to put a 6 out front. But remember, that's actually 2 to the first, okay? So what's going to go here is 2 to the third power, which is not 6, okay? The exponents are what's being multiplied. And for some reason, when there's a number here, people always want to multiply the base. We're not multiplying the y by 3, we're multiplying the 2 by 3. I'm not multiplying the x by 3, I'm multiplying that 1 in the exponent by 3. And the same thing goes with a number. Just because it's a number doesn't change anything. So now we can't really leave it like this because you can do 2 to the third. 2 to the third means 2 times 2 times 2, which is actually 8. So be very careful. That's why I try not to use that word distribute. If you're going to think about it that way, remember you're distributing to the exponents, not to the base. So you get in the habit of multiplying these exponents by 3, and then all of a sudden you want to multiply the 2 by 3. But remember, you're multiplying that exponent, which is 1, by 3. All right, moving on. Now we have a fraction inside the parentheses, which means a couple of different rules are going to be applied here. Because we have a negative sign, which means we need to flip the base. We also have a 2 that we need to raise everything in here to the second power. Okay? I like to get rid of the negative signs first a lot of times. It doesn't really matter, but sometimes it's easier to me to get rid of the negative sign first. So I'm just going to flip the base. So everything on the top went to the bottom, everything on the bottom went to the top. And you still have a 2 on the outside. Now I need to raise everything to the second power. So I'm going to get y to the sixth, 3 to the second power, which is 9. It's not 3 times 2, remember. And then x, this was a 2, so that's x to the fourth. Okay, feel free to pause these videos and rewind them at any time if you'd like to see how I did that again. It helps a lot of times to just pause it and rewind it. I go kind of fast sometimes, but it's a video, so you can pause it, rewind it, and do whatever you need to do. All right. Now, when we talked about this rule, we said you subtract the exponents. When you have like bases, you subtract the exponents. I've got another way that I like to think about it. So I'll kind of talk about both ways. If you talk about subtraction, here's what you would be doing. Well, first of all, 15 over 5, those are not like bases, okay? So 15 over 5, we can reduce that. We can do 15 divided by 5, that's 3, okay? So for the numbers, for the coefficients, you need to go ahead and just divide them out if you can. But when it comes to these like bases, x to the fourth divided by x squared, we say we subtract. So 4 minus 2 is 2, okay? Now, where it gets interesting is when you have negative signs involved. And that's why I say I like to think about it a little bit differently. If we think about it as subtraction, you're going to say negative 2 minus 3, which is negative 5. And that's going to give you a y to the negative fifth on the top. But remember, the negative exponent means we actually drop the negative sign, move it to the bottom, so you actually end up with a y to the fifth on the bottom, okay? Now, the way I like to think about it is instead, I like to look at it this way. Look at the x's. There's x to the fourth on the top, x squared on the bottom. So are there more x's on the top or more on the bottom? In other words, if I were to expand just that part out, I'd have 4 x's being multiplied together on the top, and I'd have 2 x's being multiplied together on the bottom. Well, as you know, if you've got things multiplied on the top and on the bottom, you can cancel those things out. I could cancel these out, I could cancel these out, and what would be left would be an x squared on the top, 2 x's, right? So what I like to do is say, are there more on the top or are there more on the bottom? Because if there had been more on the bottom, that's what would have been left. There's more x's on the top, there's 2 more, and so there's x squared left on the top. Now it's harder to illustrate that with the negatives, but think about it this way. Which one's bigger, 3 or negative 2? 3 is bigger, right? How much bigger is 3? If you were to do a number line with a negative 2 and a positive 3. Here's 0 in the middle. The distance between these two is 2, and the distance between these two is 3, and that adds up to 5. That's a total difference of 5 between those. The distance from negative 2 to 3 is 5, okay? In other words, if I say, which one's bigger, negative 2 or 3, you say 3 is bigger, and I say, how much bigger? It's 5 bigger, so there's 5 y's on the bottom. I know that sounds a little bit longer, but it avoids this issue of having negative signs that you later have to end up crossing out and moving, okay? So let's do another example, and I'll see if hopefully this makes more sense. 2 and 4. So we can reduce the 2 and the 4 to 1/2. So a 1 on the top, I don't need to write it, and put a 2 on the bottom. I only need to put the 1 up there if everything else cancels out. Are there more x's on the top or are there more on the bottom? There's more on the top because positive is always more than negative. And how much more is it? It's 8 more. Okay, so that means there's 8 x's on the top. Are there more y's on the top or on the bottom? They're both negative this time. So if I were subtracting, I'd have a whole bunch of sign changes to worry about. Okay, but instead, I'm just going to think about it this way. Which one's a bigger number, -1 or -4? Actually, -1 is a bigger number. It's closer to being positive. Okay, it's a greater number. So if -1 is a bigger number, how much bigger is it? It's 3 bigger. So you have y to the third on the top. Wherever there's more, that's where your leftovers are going to be. And however many more there are, that's how many more are left. There's 8 more x's on the top, so I put 8 x's on the top. There's 3 more y's on the top, so I put 3 y's on the top. All right, and those are some basic examples for exponent rules.